Okie dokie. So today we're going to be covering Unit 3, Lesson 6, Congruent Triangles by SSS and SAS. Okay, so I'm talking about here and here. And what these basically, SSS stands for side, 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 and I'll explain in a little while. And SAS stands for side, angle, side. So instead of saying, it's just basically a shorter way of saying it. Okay, let's move on. So let's go ahead and take a minute and do your do now here. We're going to push pause. So once you've taken some time to figure this one out, you realize that I'm going to use an angle sum theorem. Okay, so there's an angle sum, and then I'll just put theorem. Okay, and what it basically that all three angles are always going to equal 180 degrees, no matter what size the triangle. Whether you want to make a triangle between planets or if you want to make a triangle on your piece of paper. Doesn't matter the size, always 180 degrees. So basically I have three expressions here, right? They're not equal to each other, but I know when I add them all up, they will equal 180 degrees. So what I'm going to do is I'm going to take all three expressions and I'm going to set them equal to 180. I'm going to add them up and set them equal to 180. At which point I'll go ahead and combine my like expressions, right? All the x terms. So 6 plus 8 plus 3 is 17x. Then I go ahead and combine the numbers, or we call them constants by themselves here. It's the simple numbers by themselves. So negative 5 minus 35 is negative 40. And negative 40 minus 1 is minus 41, or negative 41, equals 180. Okay, at this point, I'll go ahead and add 41 to both sides. This goes away. I'm left with 17x equals 241. Sorry, I realize it's actually 221, not 241. So at this point, I'll go ahead and divide both sides by 17 to isolate the variable x, which is equal to 13. Okay? If I substitute this 13 here, here, and here into the x values and worked out the solution, they would all equal the same. They would all, add up to 180 degrees once you add up the three angles. Alright, let's move on. So today we're going to be talking about proving triangles using a couple of theorems. Now, we were able to realize that if we have two triangles, I'm just going to draw two pictures here. These are just two triangles. And I'll say this is A, B, C, and this will be D, E, F. Okay, now if these angles are all congruent, okay, and the sides here are congruent, then we're told that these two angles, triangles, are congruent. So ABC is congruent to DEF. This is something we've already established. We know this. We learned this a few days ago. However, because of other theorems that you're going to be learning about today, you don't always have to have all 6 pieces of information, all 3 angles, and all 3 sides. So let's look at this first one here. The SSS, or side, side, side postulate. If 3 sides of one triangle are equal to 3 sides of another triangle, the triangles are congruent. And here's what I mean. Let's take this long side here. Okay, let's say those two guys are congruent. And then let's say these are congruent. And let's take these last. If we have congruency in all 3 sides, then we can say that these two triangles are in fact congruent to one another. Okay? That's basically what SSS postulate stands for. Let's learn about another one. Now we have SAS postulate, which says if 2 sides and the included angle of one triangle are equal to the corresponding sides and angle of another triangle, the triangles are congruent. And it kind of cut off here, so this is congruent. Okay? So basically saying here, let's take for example these two triangles. Now they may not look the same, right? But we don't use our eyes. We use math and postulates to define. So sometimes things are not drawn to scale. So let's say that this side here, and let's say just that this side here, okay, are congruent. And let's also take, I'm going to do it like this. Let's say this side here, just so it doesn't have to look so perfect all the time. And then let's say that this side here is congruent to this side. And we can also establish that these angles here, right, it's called the included angle. If those are also congruent, so we basically have a side, angle, side. Side, angle, side. So here we would be able to fulfill the side, angle, side postulate to prove that these two triangles are in fact congruent. Let's go on. So reasons sides are congruent. Let's talk about reasons why sides are congruent and reasons why angles are congruent. Okay? So let's take the first part. First, sides are congruent if it's given, right? That's supposed to be a little smiley face here. So that's a smiley face. If it's given. If you're told that two sides, for example, AB, right, is congruent to just DF, for example, right? You're told that sides are congruent. That's one way to establish that there's congruency. Another reason sides are congruent is the definition of midpoint. A midpoint will create two congruent sides. What does that look like? So you may have a line like this, for example, here, right? And here, let's say this is A and this is B. Let's use two different variables or labels, X, Y. And let's say that right here in the middle, right, this is N. And let's say N is the midpoint. If N is the midpoint, let's just put NP in parentheses, then these two sides are congruent. XN is congruent to NY. Again, XN is congruent to NY because we've been told that N is a midpoint. And lastly, we're told the reflexive property. A side is congruent to itself. Okay, we'll get into that a little more in a little bit later, but basically that's just saying that if you have something like this, for example, right, you have, right, this side here, you notice is part of this triangle, but it's also a part of this triangle. And we would say that this side here actually kind of represents like two sides of two different triangles, the green triangle and the red triangle. However, that side would be congruent to itself. So that's how we would know it's also congruent. Okay, we'll go into the other part here about angles. Okay, so again, it's given. We're told that one angle is congruent to another or equals another congruency. Vertical angles. These are vertical angles. Okay, so these angles that sit across from each other like this are called vertical angles. So vert angles. Okay, alternate interior angles, alternate exterior angles, corresponding angles. Definition of angle bisector. Okay, an angle bisector will create two congruent angles. So what does that look like? So let me show you here. So let's say I have an angle like this, right? And I have this angle here. Let's say that there's an angle bisector which cuts this angle into two equal halves. This would mean that this and this angle are now congruent to one another. So let's say, for example, the entire angle, right, the big one that we had earlier, the entire piece there, let's say that was worth 100 degrees. Well, each of these little small angles here and here would equal 50 because this red angle bisector, so we'll put angle bisector, cut both of those angles into two equal parts, which now we have established congruency again. Okay, so again, all today is about congruent triangles. We're going to prove that triangles being congruent based off just given two triangles and looking at them. and establishing our postulates, of course. Okay, caution. Do not use AAA, which we know A stands for angle, so angle, 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 or the donkey theorem, right? We call this the donkey theorem, right? Because donkeys don't do the smartest things according to this, right, this title. So AAA means we are given all three angles of two triangles but no sides. So let's take, for example, you have two triangles, well, just two triangles kind of look like each other here, right? And although these particular triangles may look like one another, have the same shape, they are not the same size. However, what if I told you that this angle and this angle are congruent, this angle and this angle congruent, and these last angles are also congruent? That means nothing about the triangles. This is the donkey theorem. This says, oh, they must be congruent triangles. But hold on. Look at this little size here. Right? If that's 5, this guy over here could be 15, which means they're not congruent triangles. Okay, so we went through these in class together, but I'm just going to go ahead and note that, again, these two here, on the my turn, I have this, right, which is one leg. I have this other leg here, which is congruent over here. And together they make the included angle. That's what these two guys are called here, right? Included angle. And so these would be SAS, okay? On the bottom here, where we also determined that this would be side, side, side. Okay, so this is S, S, S. Okay. Again, your turn. Some of us thought maybe this may be SAS, but notice that the angle here is not the same, right? So this is not an included angle. I know nothing about this leg down here in red, right? So this here would be not congruent. So you can just do a statement like this. I think I did not have the thing recording, but this is what we went through here. Again, these are not included angles, right? So this is an included angle here on the first one. We notice here it's not. I put a question mark here because I know nothing about this line, this red line here, side, excuse me. So again, there's no congruence. That's why there's, so no congruence. That's what this statement means. No congruence. Okay, on the bottom here is SSS. That's kind of self-explanatory. Let's go on. Okay, my turn here. I have one side here congruent. I have the angle, so side, angle, angles congruent. And we notice that this side here, because of the reflexive property, is behaving as two sides, so it's congruent to itself. So in this case, I would have side, angle, side congruence, okay? So these are congruent. Your turn. Go ahead and try that. Push pause and try it on your own. So if you got not congruent, you are correct. Okay, these are not congruent for the reason that this side and this side, although they are congruent, okay. So although those sides are congruent, and then we could take these sides here and say, well, they're congruent as well, right? But we cannot assume that these angles, which we would think maybe they're included angles, we cannot assume that because there's no indication that there is, right? So that's why this is not side angle SAS. So if you thought this may be SAS, that is wrong, okay? This, in fact, is no congruence. So no congruence. Take a my turn here. So let's go ahead and establish some things. I have an angle, and an angle, and an angle, right? These are all, let's do this color code this a little bit better. So I have an angle here, both right angles, cool. I have this angle over here, this angle over here, all right? I can't assume the sides or anything congruence, but I do know something here. I know there's congruence when we have vertical angles, right? These are vertical angles, right? So we established earlier here that vertical angles, right there, that vertical angles are congruent, right? So those are reasons why they're always going to be congruent. So going back to our current slide, too far. Our current slide here, we determined that These are vertical angles, so these angles are congruent too, right? So now we're assuming, okay, well, if that's the case, and these sides here match up here, we say that the opposite side to those vertical angles are also congruent. But that's really the only thing we can establish. So I want to say they're congruent because everything feels like that, but if you remember, I have angle, angle, angle. And what do we call this again? I wish I could draw it, but I can't, so I'll just write it. Donkey theorem. All right, doesn't work. Go back to that slide and check it out. Okay, your turn here. All right, again, you have angle. Cool, those check out. Angle. Another angle. All right, so what? This again is A, right? This is bad. Donkey theorem. There's no congruence. Can't assume that they do. Remember, this up here could be a planet, another planet, and another planet. And this, on the other one here, I could have like 3 objects on your kitchen table. And they could all make the same angles, but it doesn't assume that the sides are congruent unless we're told that those sides are congruent. Okay? All right. So you are to go through this independent practice here. All right, I'll go through maybe 1 or 2 here with you, and then you're going to finish them off, as well as the exit ticket at the end. Very important, the exit ticket at the end. Okay, so let's kind of go through this one here. State whether the triangle could be proven congruent, if possible, by SSS, SAS, right? If possible. It could also be not congruent. And if it is, then write a congruency statement. So let's take a look at this first one here. In this first one here, I have QY here, and it looks congruent to this right here. I have YT, which shows its congruence over here, to KP. Okay, so we got 2 sides, and I see that they both make the same included angle. This is congruence by SAS congruence, okay? So this is good. This checks out. Let's look at the other one here. I have 2 sides here. I have another pair of sides here that are congruent. Okay? This third side is really just one line segment, but because of the reflexive property, a side is congruent to itself. So in fact, it has, I'll do it in red here, it stands out. It has 3 there to itself. We would never write that, but we know that that's understood. Okay? So this would be side, side, side. So you will work through this slide and this one. You're doing the same thing I just did for this one over here, for 1 and 2. So you do 4, 5, 6. You'll go through these as well. So we'll write a postulate here. So write which of the SSS or SAS postulates, if either, again it could be not congruence, can be used to prove the triangle's congruent. If no triangles can be congruent, you can write neither. Or you could just write this little symbol here with a line through it. Shows not congruent. Okay, I like that a little bit better. So let's look here. We have 2 sides, cool, that are congruent. We have an angle here, right? They both kind of make this side here that attaches to this angle here, right? Can we know anything about these? Let me do a different color. This side and this side. And we don't know anything about those sides actually, so we're not given any information, so that doesn't help us. We had one in our last example, but that one had kind of like angles in here, which determined that this line, because of the reflexive property, gave us a chance to say that that was side angle side. But in this situation, right? If I erase everything off here, right, just take a look here, all we have basically is two congruent sides and a congruent angle. There's not enough here. So this would be not congruent. Okay, or you can write neither. That's fine. All right, so you'll move through 2, 3, and 4 on your own. And number 5, I'll let you play with that one. And then we have this one here. And then exit ticket. Of course, very important. Which pair can be proved congruent by SSS? So, you know, if A, B, C, and D can be, you'll circle those, okay? You'll let me know. And you maybe have some markings here that show what's going on, that you know your stuff, right? So, yeah, that's it. Make sure this exit ticket is done. This is going to be a grade. Thank you all very much, guys.